All right, so good afternoon, good morning, good afternoon, everybody. My name is Elena. I'm a marketing director at Rosatom Overseas at Rosatom, a nuclear state corporation of Russia. And I'm going to be speaking today to you about the developments in the small modular reactors that we have experienced within Rosatom, about our achievements by this day, and about our plans and next steps that we expect to take in terms of SMR's development. Just since we have quite an impressive audience today, I see about 200 people online watching us. I'll speak shortly about Rosatom as a nuclear vendor, what we do, who we are, and then I will move on to what we particularly do in terms of SMRs and how we work in that sector. All right. So Rosatom is a state nuclear corporation, a huge one. We unite more than 300 subsidiaries and employ over 250,000 employees. We are a leading nuclear vendor in the world. We do business in over 50 countries around the globe. And we are #1 vendor by large-scale classic nuclear power plant unit construction overseas. Our construction overseas nuclear power plants construction portfolio is 35 nuclear power plant units in this overseas nuclear construction portfolio. Rosatom is also a large utility. Last year, we set a record of power generation in Russia. So Rosatom is both a vendor and a leading generating company in Russia. Actually, it is important to say that our core business is large-scale nuclear power plants, indeed, and this is well known. However, small modular reactors for Rosatom is not something new. Ever since 1954, so it's been a long history since when we have been developing small reactors already, but they were for marine applications, and I will speak about this because this is actually the basis on which we are now building the innovative solutions in SMRs. The designer of small reactors for marine applications is a subsidiary of Rosatom, a design bureau of KBM Afrikantov. It has overall designed and manufactured over 20 small reactors for civil marine applications. And this is actually a great experience of safe construction and operation of SMRs for the icebreaker fleet. We currently have over 400 reactor years of experience of SMR's operations. So this is great to understand that for us, SMRs are kind of a combination of experience and innovations. So this combination makes us really very ambitious in terms of SMR technologies further development. This is a story of the icebreaker fleet. The history. We have constructed 11 nuclear icebreakers, and in operation we now have 6 of those and 1 lash carrier, all run on small reactors. 4 of such icebreakers of a new type are currently being constructed, and they will also employ SMRs. Okay, and the base, as I mentioned already, but I love mentioning this over and over again, that basing on that experience of design, manufacturing, and operation of small reactors for icebreakers, we developed the first floating, the world's only currently operating floating nuclear power plant Akademik Lomonosov. We actually sometimes receive a question, how did the idea come to minds from the icebreakers to a floating nuclear power plant to generate electricity? The answer is very comprehensive, and this answer is relates to Russia, but basically the reasons why this type of a nuclear power plant is so important, they are attributable to many other regions globally. So basically, Russia is the largest country in the world, and we have a big amount of remote regions. They occupy over than 50% of the territory of the country, so remote areas. Over 20 million people live in those remote areas, and they need electricity and heat for their lives. We also have reserves of minerals in those regions, which also have to be developed. Those northern remote regions are located in decentralized energy supply zones, which makes energy supply an issue down there. Traditionally, fuel transport costs account for about 80% of the electricity price there. To take fuel down north to those remote areas is extremely expensive. So those regions definitely needed a solution not dependent on fuel costs and fuel delivery. And the infrastructure in such remote areas, such as road, grids, is definitely not ready for not connect. It's decentralized and not ready for receiving electricity from big cities. And a floating nuclear power plant actually was just a solution for such regions, for regions of such type, which I have just described. Going into details, the floating nuclear power plant, this is the one located now in the northern part of Russia, is equipped with 2 KLT-40S pressurized water reactors that can generate up to 77 megawatt of electricity or up to 300 megawatt of thermal power. The reactors are very much similar to those used at icebreakers. So the reactors at icebreakers are the predecessors of these ones. And one of the biggest challenge was to maximize the period of uninterrupted operation at site. And currently, as you can see in the slide, there is the fuel storage on board and the refueling system on board, which basically eliminates this problem of loading, unloading, and maintenance of the power plant. The fuel cycle is 3 years, and the maintenance period is up to 10-12 years. The lifetime is 40 years with possible extension, as it typically happens with nuclear power plants. Some facts about how it was commissioned. In December 2019, it was the floating nuclear power plant was connected to the grid and started supplying first electricity to Chukotka grid in the northern part of Russia. In May last year, 2020, it was fully commissioned and became the 11th nuclear power plant in Russia and the most northern one in the world. So answering the question, what is the most northern nuclear power plant in the world? The correct answer is that it's the floating nuclear power plant in Russia. In June last year, it supplied first heat to the city where it is located, and currently it ensures 50% of the region's demand. The US Power Magazine, that's a very important fact for us, named this the event of commissioning of this floating nuclear power plant one of the 6 key global nuclear energy industry events of 2019. Okay, moving on. What now? What is going on now down there? Today, the floating nuclear power plant provides reliable and clean which is very important, making the snow whiter down there north. A reliable and clean heat and power supply to living areas, and also, which is very important, ensures the industrial development in that region. In the future, this floating nuclear power plant will replace the aging now Bilibina nuclear power plant that exists there, and what is very important in terms of the net zero path goals, it will also replace the coal-fired thermal power plant down there. So environmentally, the project is very beneficial for the region. Next steps, as I promised, I will speak about what we are doing next after commissioning the first and only floating nuclear power plant with SMRs. We launched the floating nuclear power plant with the KLT40S reactors, but we are developing the SMR technology, and now the flagship SMR solution of Rosatom, which incorporates the features of the predecessors at icebreakers and at the floating nuclear power plant. It is the RITM or RITM series SMR. It is a PWR technology, and the technology has already proven its safety and efficiency. The innovative features here are the integral configuration of the reactor. The dimensions are therefore logically reduced compared to the KLT40S reactor installed at the floating nuclear power plant. The dimensions are refused by smaller by 45% in terms of in dimensions, and by 35% in terms of mass compared to KLT40S. The integral design almost eliminates the possibility of the large-scale loss of coolant accident. I will not speak about safety systems a lot because we're not in a technical seminar today, and we are very much open and provide the information in the IAEA booklet about the systems of the reactor. So we welcome our colleagues and partners to learn about this from the IAEA booklet, but basically the high safety level of RITM series reactors is achieved by both inherent safety features and the combination of passive and active safety systems. There is a set of physical barriers and Rosatom Beyond Design Basis Accident Management System. Important to mention that this RITM series SMRs are not a PPX design, but it's already a reference technology because 6 state-of-the-art RITM series SMRs have been manufactured and installed at icebreakers, at the multi-purpose universal icebreakers that are currently being constructed. These are unique icebreakers with the RITM series SMRs, and they will have variable draught and will be able to navigate both shallow rivers and deep seas. Really unique objects. In October last year, one of these icebreakers with RITM series SMRs successfully passed all the sea trials and was commissioned and began its operation. I would like to stress it that it's an icebreaker with the RITM series reactor already. It became the most powerful icebreaker in the world, and it can break the ice up to 3 meters. 4 other icebreakers with RITM series SMRs are to enter operation this year, and consequently 2022, 2025, and 2026. We are now developing a full, as we say, family of RITM series reactors. It means that they are versatile. This RITM series SMR is versatile and can be considered for different applications, for icebreakers, which is already happening, for land-based nuclear power plants of small capacity, and for floating nuclear power plants of the next generation. Key parameters are presented in the slide. You can see that they vary a bit in some of them, dimensions particularly, and capacity, but basically they are all presented here. Okay, I will speak now in more detail about the land-based nuclear power plant with this RITM series SMR, and about the floating nuclear power plant with the RITM series SMR. Okay, I shall start with the floating one. This should not be mixed with the floating nuclear power plant already in operation, which I spoke about earlier. This is the optimized floating nuclear power plant. And this will be already having the RITM series reactors. We are developing these each floating nuclear power plant will have 2 reactors of 50 megawatts each. Compared to the operating floating nuclear power plant, this one will be more compact, will have more capacity, and will be more efficient. The electrical capacity thus will be 100 megawatts, 2 reactors, 50 megawatts each. Increased fuel cycle, and the design life, again, 40 years plus. Last year, we completed the conceptual design stage of this project, and we are now moving to a technical design stage. Let me briefly speak about the advantages of such a solution. Definitely, we don't need to speak about the advantages of the nuclear power generation here at this forum. And we understand that the floating nuclear power plant shares all the advantages of a conventional nuclear generation, such as predictable electricity prices and sustainability of supply. But also what is important with this floating nuclear power plant is the shorter period of construction. Basically, it is constructed at the shipyard and delivered as a ready-made solution to the operation site. They are also very flexible in terms of placement and can be transported to another site. We can say that the main idea that we follow with these type of energy solutions is that this floating nuclear power plant can ease the burden on the on our partner, on the host country, in terms of fuel handling, human capacity development. So this is basically a plug-and-play solution, and really an efficient one, as we see it, and we are sure in that. Let me move on to the land-based SMR nuclear power plant, also based on RITM series reactors. Okay, so we are developing this based on the RITM series reactors. You can see that the capacity of each reactor for the land-based nuclear power plant is a little bit increased. It's 55 megawatt each, so totally it makes 110 megawatt for the small modular reactor-based nuclear power plant. But this is modular, so the capacity can be definitely increased. You can see the parameters in the slide. Thermal capacity is 380, refueling cycle 5 to 6 years, design life 60 years, and the construction period 3-4. I also indicate in this slide the possibility of other applications, electricity and heat and desalination and hydrogen production. These applications are mentioned by my colleagues in presentation during this conference, so I'm happy to mention these applications as well for our design. It is important to say that in Rosatom we follow the policy to offer the market only reference solutions. And as our Director General says, an important aspect of our foreign practices is that Rosatom always follows the principle, first we build in our own country, and then we offer the technology to international markets. And that's why we are currently getting ready for the first of a kind SMR-based land-based nuclear power plant in Russia. We are considering several sites for this project. The sites are different in terms of geography and climate, and this means that such a project can address a wide range of needs and is really still can be tailor-made, though being very already referenced. The timeline is in the slide, and by 2028, we expect to commission the power plant. Okay, this is the news from December 2020. On 23rd, if I'm not mistaken, on December 23rd in 2020, so it's like a month ago from today, Rosatom and the government of Republic of Yakutia in northeastern part of Russia signed an agreement to develop an SMR project in that region, SMR land-based nuclear power plant. It's an area with an isolated grid. Overall, about 10,000 people live there. The region is really rich in mineral resources with precious metal deposits and others. And it is expected that the SMR nuclear power plant project there will definitely have extremely positive effects for the industry development, for the economy, and for the living conditions of the people. So it's multiply beneficial for the region. It is expected that due to the predictability of the cost, the cost of electric power in the region will receive huge benefits, because currently the region is very remote and the tariff and the electric power costs are really high. The project will also supply clean energy and heat down there, because they now mainly supplied by diesel generators, and heat is supplied by coal boiler stations. The project will also contribute to the CO2 reductions in the region, which is important. Energy independence of that region will increase, and energy intensive industries will be able to be developed. So the region will receive, as I mentioned, I'm repeating myself, but it's so important that the region will receive both economic, industrial benefits and benefits for the people living there. We can say that up to 800 new jobs can be created by such a project of NPP construction and consequent mining and processing plants developed there that can be powered by the nuclear power plant. And finishing this talk, I just would like to leave you with major ideas that I spoke about. Rosatom launched and commissioned the Akademik Lomonosov floating nuclear power plant in Russia, equipped with 2 SMRs of KLT-40S type. It is successfully operating. Rosatom is developing the RITM series SMRs for both land-based location and floating location. This technology is safe, and the safety is enhanced by the safety systems and the design choices and active and passive safety systems. And we are working currently and focused on the first of a kind project of the land-based nuclear power plant with SMRs in Russia. I'll be ready to answer your questions. I hope you enjoyed this information, and I thank you for your kind attention. Thank you.